AP Cram, Calculus AB, Free Response Exam Review. Question 11. Compute average velocity using integration. Bob is riding his bicycle along a path, okay? Ignore the same. For t is either greater than or equivalent to 0, and the 0 has a unit of minutes, or less than or equivalent to 10 minutes. So this is a time interval. Bob's velocity is modeled by b of t is equivalent to t to the third power minus 6t raised to the second power plus 300, where t is measured in minutes and b of t is measured in meters per minute. Based on the model B, or we could also say B of t, this model mentioned here, find Bob's average velocity during the interval t is either greater than or equivalent to 0 minutes or less than or equivalent to 10 minutes. Okay, so what's the strategy for finding the average velocity? I'll give you a moment to think. Basically, we're told that we have the model B of t, and this is basically our velocity. What you have to do is use basic antidifferentiation through integration to find the distance traveled, and we know that average velocity is total difference over the total time traveled. Then you're going to divide it by a total of 10 minutes traveled, okay? So the 10 minutes is not within, the division by 10 minutes is not within the integral. It's outside of the integral. So it's written outside from the jump, okay? So when you distribute integration for each term here, you're going to wind up with 1/10 t to the 4th over 4. And this t to the 4th over 4 comes from the basic antidifferentiation rule that says the antiderivative of, let's say, t to the 3rd power is going to be t divided by n plus 1 raised to n plus 1. So it's like the opposite of differentiation, where in this case n is equivalent to 3. So n plus 1 is 4. Raised to the n plus 1 here is 4. Okay, same thing here. So our t to the n plus 1 is going to give us our antiderivative. So n plus 1 is 3, and divided by n plus 1. So division by 3 is going to yield a -2. And if we imagine that there's a t to the 0, so t to the 0 plus 1 is going to be t to the 1st power divided by 1 is going to give us 300t. So we now evaluate this expression between our bounds of integration, which the lower bound is 0 and the upper bound is 10. And so we get, well, anywhere where we put in a 0, the terms are going to cancel out, okay? So we only have to evaluate it at 10. And so we get 10,000 over 4 minus 2,000 plus 3,000. And what we wind up with is 350 meters per minute. And the minutes come back in because we divided by 10 minutes, okay? All right.